What's up, guys? Happy Wednesday. Hope that these digital learning days are becoming easier and easier every day. Um, Today, we're going to kind of shift gears a little bit. So, obviously, we're still staying with quadratics, but what we're going to do today is we're going to compare quadratic functions in different forms. So, we've been learning ever since the beginning of the school year that when we're talking about equations, graphs, tables, those are three different ways to represent relationships, right, between quantities. So we know that quadratics can be represented by a graph, by a function or equation, and by a table. And we've got to be able to compare all three of those side by side and be able to tell different things about each. So that's kind of what we're doing today. Again, when you get done with this video lesson, jump over on Canvas, do the practice quiz, and don't forget, these are just graded for effort, not accuracy. So even if you don't do so hot, that's okay. Just grading it for effort. I know these online learning lessons can be tough, so don't stress about that. So, hey, let's jump on into this first example. So, I have two completely different quadratic functions here. This function we're going to call f of x, and it's represented by a graph. This function we're going to call g of x, and it's represented by an equation, right? And what this question is asking, it says, which function has the lesser minimum value? In other words, which function has the lowest minimum, right? And if y'all remember, every quadratic the graph of the quadratic looks like this, right? We call this a parabola. And I know if I'm talking about the lowest value, I'm talking about which point? The vertex, right? Same if it said what's the highest maximum value, we know that that would be if the parabola opened down, right? That vertex is the lowest point or the highest point on a parabola. And you guys know that. So if we have one that's a graph and one that's an equation, we got to be able to figure out the minimum value for each. So obviously, the easier of the two to see the minimum is the graph, right? We can see this minimum right down here. -1, -1, right? That means the minimum value is that -1 y value, right? It's the lowest point on the graph. So we need to figure out what the minimum value is for g of x to be able to compare the two, right? So obviously we don't have this graphed, right? I guess we could graph it, but I think the more straightforward, easier method is to go ahead and find the vertex of this function, right? And if you remember correctly, this function is obviously written in standard form, ax squared plus bx plus c. So I've already got this worked out, but you guys know how to find the vertex from standard form, right? First, you find negative b over 2a. This is our axis of symmetry, right? And when you do that, b is 8. Obviously, a is 4. So negative b over 2a. When you simplify this down, you get -1, right? That -1 I know is going to be the x value of my vertex, right? So I have the x value of my vertex. I just need to find the y value, right? And if you remember the way we do that, take that x value and evaluate the equation at that x value, right? Find g of -1. In other words, you're plugging -1 in for x, right? Which is what I've done here. And you can just plug this straight into the calculator. Be mindful to put that -1 in parentheses. That way, the calculator does the work correctly. And sorry, my dog is messing with stuff in this room. When you evaluate this into the calculator, you get g of -1 equals 3, right? That means our vertex, we found the x value is -1, the y value is 3. So this is my vertex for g of x. Do we have everything we need to answer the question? I think we do. So which function has the lesser or the lowest minimum value? Well, this one, the lowest value is at 3, the y value of 3. This one, the lowest value is at -1, right? What we could do is we could honestly graph this vertex on this graph to compare it side by side, right? -1, 3 would be, well, if 1's right here, it would be somewhere up here, right? So obviously, which one has the lowest minimum value? Well, we'll answer the question. It's going to be f of x. Let's move on to the next example. So last example, we compared a graph and an equation. This example, we're going to compare a graph and a table, right? It says which function has the lower minimum? Same question as last time, but two completely different functions. And again, remember, this table and this graph are two separate functions. They don't go together. They don't represent the same function. So which one has the lowest minimum? Well, let's go ahead and find the minimum of g of x is right here, right? We went over 2, down 10. That's 2, -10 as my vertex. So my minimum is -10. Now, remember, how do we find this from a table? We're looking for, starts with an S, symmetry, right? If you're looking at these y values, we can see the symmetry, right? -6 is that kind of middle value, -5, -2, -5, -2. So we learned when we see that, we can tell our vertex is that point right there, 1, -6. So which one of these functions has the lower minimum value? Again, it's going to be g of x, because this one, the lowest value is -10, whereas this one, the lowest value is -6. Let's do one last example. So how many x-intercepts do these functions share in common? So this is a different question, right? We're not talking max or min in this case. We're talking x-intercepts, right? Again, we have a function as an equation and as a graph, two completely different quadratic functions, right? G of x, f of x. If we start with the graph, we see one x-intercept here, and we see the other x-intercept here. So our x-intercepts for the graph are -1, 0, and 2, 0. Now the question is asking, like, what x-intercepts do they share in common, right? Well, we have them for the graph. Let's find them from the equation. This jumps back to Tuesday's video lesson where we learned how to find x-intercepts by converting to intercept form, right? And if you remember, another word for intercept form is factored form. So we're going to take this function and we're going to factor it. Obviously, it's in standard form, right? It's in standard form, and a is 1. We like those because now we know that we can factor this into x and something times x and something, right? And how do we find these numbers? We need to figure out the two numbers that multiply to c and add to b. So what two numbers multiply to -14 and add to 5? That would be a +7 and a -2, right? And let's not forget, this is g of x. So this is my factored or intercept form. And what we learned on Tuesday was how to find the x-intercepts from intercept form. And hopefully you remember, whatever these signs are in here, you've got to change to the opposite sign. So our x-intercepts, this +7 means one x-intercept is -7, 0. And this -2 means another x-intercept is +2, 0. So the question says, how many x-intercepts do these functions share in common? Well, the x-intercepts of g of x are -7, 0, and 2, 0. Those are the 2 points where that function crosses the x-axis. F of x, the two x-intercepts are negative 1, 0, and 2, 0. So obviously we see they share 2, 0 in common. So how many x-intercepts do they share in common? The answer is 1. And that's the last example I'm going to work out with you guys. Go ahead and go over to Canvas, try out the practice quiz, email me, message me on Canvas, message me over Remind if you got any questions, and have a great rest of your Wednesday.